am Greg Stone. For the first half of my career, I worked for a large electric power company, basically becoming a motor and generator testing specialist to evaluate which machines needed to be removed for maintenance. And then we had a few ideas then, and then myself and several other colleagues at Hydro, it's called Ontario Hydro then, decided that we could start a company selling some of this equipment. And so we started a company called IEEE Power. Now I'm retired. Doesn't matter what I do. My interest has always been motors and generators, and specifically the electrical insulation in them. What I've seen is the tremendous increases in stresses, both electrical, thermal, and mechanical stresses acting on the motors and generators. And this has precipitated more rapid aging of the electrical insulation. And this has then created a need for more diagnostic testing and more advanced assessment techniques of the windings. Well, the real big issue or transition, at least in my particular sphere, is the introduction of variable speed drives, okay, which create a lot of voltage impulses with very short rise times, now getting down as short as 20 nanoseconds. And our most common diagnostic technique is measuring partial discharges. And those partial discharges have the same kind of frequency characteristics and time characteristics as the impulse voltages, which are 10,000 times bigger coming from the drives. And so the main research I think that needs to happen over the next few years is coming up with diagnostic techniques that can be applied, and they must be cheap and efficient, because we're having motors in electric vehicles, they're failing, okay? And the only way we know of how to detect that before the actual failure is by using something called partial discharge testing. Well, of course, the big hope for insulation material improvement really comes from nano dielectrics. You know, the small little particles that are added to a resin to make it, to improve its voltage endurance and thermal conductance and things like that. And so there's a lot of materials chemistry. But aside from very isolated cases for electric insulation, none of that has really been proven effective, okay? So there's a lot of work on nanodielectrics, but it really hasn't, in my opinion, seen the real commercial acceptance it should have. And so there's a lot of work on chemistry that needs to be done.